So we are looking for the new geodesic strategy in Fusion 360, and so I let you watch how it works. And you can see the glass of water and almost nothing is moving, just a little bit, and that's all. So one of the advantages is that the machine is getting no shock. You will see here when it will make it 180 degrees, no shock. So it's a very smooth process. It starts from here, it comes here, it turns, and it goes down. And it will finish like this at the end. So that is the Fusion 360 geodesic toolpath, and I like it very much. But the problem is that the file on UC-CNC on Fusion 360, because I ask very high accuracy, is half gigabyte, which is 500 megabytes. So I cannot tell you the level of accuracy I asked numerically with the 3D design and for the toolpath. This is insane. It's around 10 micro. But the good news, very good news, is that UC-CNC is capable to manage a file of 500 megabytes. And the first minute, it was not capable to sustain more than 50% of feed rate, but now I am at 90. Okay, this computer is quite powerful, so it helps a lot. And I'm also using a new generation of hard drive, which is a memory drive. The data access are quite fast, which of course make a difference. But that's the good news. I wanted to test a very heavy file, and everything works perfectly. So we will see. This is a ball nose of 2 millimeters diatron. It's running now a little less than 12,000 RPM. We're gonna to look. So I think that the finish will be superb. I will need very little sanding to get the surface finish, the last surface finish. Okay, I want to show you how smooth the geodesic path is smooth. I didn't polish or green anything. This is like a native from the mold, and this is the geodesic path that is here on the rudder. And so the toolpath is so smooth that I need to make a big zoom with the camera so you can guess where is it. So we can compare with another toolpath, and so now you can see the difference. And that's pretty fine because in this area, where is it? In this area, we can see the curve of the geodesic path. I'm sorry, but it's so difficult to maintain the camera. Of course, with the finger, there is nothing that you can feel. So I will try maybe to get this here. So very happy with this Geodesic toolpath. You have two variants, scallop and flow, and I used the flow on the left, the Geodesic toolpath that I've used with Fusion 360, and the classical parallel that is most used for wings rudders. Generally, the toolpath is about a mill of 2, 3, or 4 millimeters. Generally, a flat hand mill. I used a ball hand mill. In fact, I have used the same ball hand mill 2 millimeters for both strategy. So it helps to the comparison. And the bit is a high quality bit because this is a Datron. That's this one. Don't know if, yeah, that's a Datron 2 millimeters ball nose. First of all, I would say you have a fine rod that is drawn by the 2 millimeters. So the wave have less than 2 of 100 millimeters of differences. This is a parameter I set up in Fusion 360. And when you touch, it's totally curvy, it's totally smooth. Now, with the parallel one, you can see right now some wave. And when you touch, you can feel these waves. And also waves in the curvy surface. The wave between the step over, and I asked the same than the geodesic, they are more pronounced. I have asked the 45 degrees, so it was not exactly like this, it was like this. Because normally it gives more freedom to get a nicer edge here. So definitively, the result is really better with the geodesic path.